hopefully you've had an opportunity to work through these problems on your own. This last problem is taking all of the different types of reactions that we've learned about, and we're trying to now just identify that from the list of reactions we have, what's going on. So let's take a look at these and try to assign the types of reactions that they are. So looking at our first one, A, I'm noticing a couple things. First of all, my eyes immediately drawn to the fact that we produce a gas as a product that is not at all part of the reactant. So the only gas in this reaction is the product. And so this tells me that this is going to be a gas evolving reaction. But continuing to look at it, I also noticed something else. One, the zinc has a plus or has a 0 oxidation state in the reactants. I mean, it's a neutral element. And when I look at it in the products, I see that it's an ionic compound with chlorine. And so that means it has to be +2. So that tells me that something's going on here where it's a redox reaction too. If I look a little bit deeper then, I notice that my hydrogen in my hydrochloric acid would have an oxidation state of +1. And in my hydrogen gas, that has an oxidation state of 0. And so I have a change in oxidation states, which makes this a redox reaction as well, right? It can be more than one type. And so I can see that my zinc is losing electrons. It's becoming more positive, so it's being oxidized. And my hydrogen is gaining, and so it's being reduced. Okay, let's look at the next one. So looking at this one, what my eye is drawn to is the water immediately in the product side. And I'm also seeing that I have a salt. Looking at my reactants, then I can see that one of my reactants contains that OH and one contains the hydrogen. And so this production of water and salt tells me this is an acid-base reaction. RXN is my way of abbreviating reaction. All right, going on to C. All right, so this is a big one. It's got a lot of things going on, but what my eye is immediately drawn to is the carbon dioxide and water product. I'm like, okay, that looks like a combustion reaction. And I can confirm that for myself by looking at the reactants and seeing that one of my reactants is just oxygen. And so this is going to be a combustion reaction. It is also, of course, then a redox reaction. Is it a gas evolving reaction? The products are gases. But if I look at my reactants, one of my reactants is also a gas. So I'm not going to see a bubbling. So I would leave it just at redox and combustion. All right, next one. I've got mercury chloride and iron forming mercury and iron chloride. This is another one where I can see that there is a change in oxidation state. And the big tip off for this one is that I have an element in its elemental state for a metal, and then I have an ionic compound. So I know that that iron now is charged. And so just looking at this, I don't have to go through all the oxidation states. I can just say, look, one of these is 0, and then it becomes +2 because it's in an ionic compound. And so just that piece alone allows me to identify this as a redox reaction. Okay, last one. So looking at our last one, I see a lot of aqueous phases, but my eye's drawn to this solid phase in one of the products. So immediately I'm like, maybe a precipitation reaction. I can then take a look at it and see that the solid that I have here is coming from the anion of one of my reactants and the cation of the other. So this is then a double replacement or precipitation reaction. And either assignment is fine with me.